This is Arthropleura, the biggest millipede species to ever crawl the earth. Its massive body was covered in hundreds of legs, stretching over 8 feet long and nearly 2 feet wide. In this ancient forest, it ruled the ground with no predators in sight. We're in the Carboniferous period, a time when planet Earth was crawling with enormous insects and other oversized arthropods. That's why it's often called the Age of Giant Bugs. So what made these creatures grow so big? The answer lies in the air they breathed. Back then, the world was packed with dense plant life. Through photosynthesis, those plants pumped out huge amounts of oxygen, enough to push atmospheric oxygen levels up to 35%. For comparison, today's air only has about 21%. That extra oxygen was the key. It allowed arthropods to grow far bigger than anything alive today. Arthropleura didn't breathe through lungs, but instead used tiny air tubes along its body, and with all that oxygen in the air, that was more than enough to power its massive frame. With no enemies and all the oxygen it could need, this giant millipede had it made. Now it's mating season, and for a male Arthropleura, that means one thing: find a mate. But that's easier said than done. Believe it or not, these creatures had no eyes. Everything they sensed came through 2 long antennae on their heads. Luckily, their thick armored plates helped protect them as they wandered around, bumping into the world. Back then, the forest floor wasn't covered in grass like it is today. Instead, it was a sea of ferns stretching for miles. Finding a mate in that kind of environment, like looking for a needle in a haystack. Still, there was hope. When females were ready to mate, they left behind a scent trail as they moved, like breadcrumbs in the dark. Males could pick up on that trail and follow it, hoping it would lead to the one. And for this particular male, that scent trail was his lifeline. After a long, clumsy trek, he finally found her. But without sight, even standing inches away didn't guarantee anything. The female was asleep. Meanwhile, the male kept circling, tracing every inch of the path she had walked. It wasn't easy, but persistence paid off. He eventually reached her side. This was his moment, and he didn't rush it. Instead, he started a slow, rhythmic courtship ritual. By rubbing the plates of his shell together, he created a subtle sound, a kind of prehistoric love song. The gentle vibrations woke the female. His efforts were working. She responded, accepting his unusual but oddly touching display of affection. They wrapped themselves around each other, moving in sync, sharing this primitive yet beautiful moment, one of the oldest love stories in Earth's history. Cut to 4 billion years ago, this place has seen it all: the rise and fall of entire biological empires. From the very first spark of life to the wild and endless variety we see today, it all follows a few simple rules. And the most important rule of all: survival of the fittest. Take these butterfly eggs. They may look exactly the same, but each one holds a completely unique set of genes. No two are identical. Some of them carry traits that give the caterpillar a better shot at survival. And those traits get passed on generation after generation until eventually what hatches looks nothing like its ancestors. It's evolved, adapted to thrive in its world. But it's not just the caterpillars that are changing. Everything in the forest is locked in a constant battle to survive, even the plants. To fight off hungry caterpillars, some plants evolved a clever defense: toxins in their leaves, deadly to anything that dares to eat them. It's an all-out chemical war. Then comes a new kind of caterpillar, one that can handle the toxins. And as a bonus, it snacks on butterfly eggs too. So butterflies adapt again, laying their eggs only on plants that don't already have eggs, giving their young a better shot at survival. But the plants fight back. Some evolve to grow tiny bumps that look just like butterfly eggs, tricking females into thinking the spot's already taken. And it gets even more devious. Those fake eggs release a sweet liquid that attracts ants. And ants, they're more than happy to hunt down and eat any caterpillars they find. That's the game of life, a non-stop race to stay one step ahead, because in nature, only the fittest survive.